and welcome. My name is Sian Salmon and I am a current PhD student here at Edinburgh University investigating physiology in freestyle disco dance. I also completed this MSc course in 2017. This session will give you a very brief overview of physiology for dance. I say very brief because physiology is a massive branch of science and to cover it all in one session would be impossible. But it is important to understand that all the systems work synchronously. With that in mind, I am going to briefly introduce what physiology involves overall and the systems involved, and then discuss the role of these systems in relation to dance performance. Exercise physiology is the study of how the body responds to physical activity. It asks how the body's functions are altered during exercise and how do they work together to regulate the body's internal environment, or homeostasis. Study can range from the system level, for example the cardiovascular system, to the subcellular level, for example the production of ATP for energy. Physiologists are interested in both acute responses and chronic adaptations. Acute responses are those occurring during exercise, and chronic adaptations are the training effects from repeated exercise bouts. Sport physiology applies these concepts to training athletes and enhancing sports performance. This also includes dance. I've written dance separately as it continues to be a fight for recognition in sport research, and different styles and their teachers and dancers have different opinions on whether dance is an art, a sport, or both. These are the branches of physiology of most interest to exercise, sport and dance physiologists. They all work together to both enable you to perform physical activity whilst maintaining homeostasis, or a stable internal environment. The musculoskeletal system is responsible for creating movement. The energy systems break down fuels and produce energy for work. The cardiovascular system is responsible for the transport of blood, oxygen and nutrients to the tissues, removal of waste products from the body and dissipation of heat. The pulmonary system is important for the exchange of oxygen and carbon dioxide between the air and blood. The nervous system controls movement and body functions, and the endocrine system is important for regulating or releasing hormones during exercise. Although each system has a job, they must all integrate for those jobs to be effective. We will look at this in relation to dance performance soon. Most research in dance physiology looks at cardiorespiratory fitness and/or anaerobic capabilities of dancers. Physical parameters such as strength and flexibility, the energy systems used or intensity of dance styles, or parts of dance styles such as class versus performance. The reason for these more descriptive profiling kinds of research may be because dance research is still a relatively new area, especially for styles outside of ballet and contemporary, and having a basic knowledge of the fundamental requirements for each style or condition within the style is important for understanding what further developments are required to keep the dancers safe and healthy and later optimize performance. So thinking fundamentally, we're going to look at two performances of different styles and perform a gas analysis test to try and understand the fundamental physiology of the two styles. A gas analysis test can allow us to find out some fundamental physiological characteristics. Here are a couple of pictures from the recording day in November. That's me fitting the gas analysis equipment to Wei Chen, and Aijia performing wearing the equipment in the second. Wei Chen and Aijia performed a routine in their respective styles, and we recorded the live data produced, and we will see this soon. I have included instructions at the bottom of this slide for you to enroll on the Labs Skills course, where you can find videos on how to use the equipment available in the labs and information on protocols, etc. In this instance, we're going to see some acute cardiorespiratory responses to the two dance pieces, which may also indicate to us the intensity of each dance piece and the energy system that is primarily utilised. Let's look closer at the types of data we will see and what is happening in the body for these to occur. The cardiorespiratory system has two main functions: to transport oxygen from air inhaled to the muscles and working organs, and to remove waste products such as carbon dioxide. As we exercise, the need for blood to circulate around the body increases. The muscles need more oxygen to continue working, and more waste products are being produced, which need to be sent back to the lungs to be expired. In order to keep up with this demand, our heart rate increases, and we would expect to see these increases directly in proportion to the exercise intensity. So the harder we work, the more our heart rate will increase. If we work at a steady state, heart rate will plateau. As we continue to exercise or increase the intensity of the exercise we are undertaking, more carbon dioxide is produced in the muscles and needs to be released from the body before it becomes toxic. High concentrations of carbon dioxide will be detected by the nervous system, which signals the brain to increase how often we breathe, or our breathing rate and ventilation. It also signals to our heart that we need to move blood around the body quicker. We will look out for the work of the cardiorespiratory and nervous systems in our live data soon. Depending on the intensity and duration of the exercise we are doing will depend on where we get our energy from. I'm going to very briefly give you an overview of the energy systems, but if you've never heard or read this before, don't worry, I have references to direct you to at the end if you are interested in learning the processes more in depth. ATP, or adenosine triphosphate, is our energy currency, and we must reproduce it constantly when we exercise. In the first 40 to 60 seconds of exercise, our body can utilize and reproduce ATP anaerobically, with our phosphocreatine stores in the first 10 seconds and glucose or glycogen in the next 30 to 40 seconds. These systems work without air or anaerobically, and are the primary energy systems for short duration, high intensity performance. Performances that last longer than a minute are naturally of a lower intensity and can use oxygen for energy production. Breaking down oxygen is a slower process, which is why it cannot be done at high intensities of work, but it does produce a lot more energy eventually, which is how we can sustain lower intensity exercise for a long time, such as jogging. It is important to remember that all the systems are working together at the same time. When it comes to dance, it is not easy to say that a style as a whole utilises one energy system primarily over the other. Many dance styles, classes and performances have been described as intermittent, not rhythmically even, with periods of low intensity and bursts of high intensity, a regular part of many dance styles. As such, there is a complex interplay between systems that cannot be generalized to dance as a whole and must be examined to styles specifically, and even down to individual classes and performances in some cases. Some previous research have described the physiological characteristics of different dance styles. Bria and colleagues have described dance sport, ballroom and Latin as of a moderate duration and high energy demanding of both aerobic and anaerobic systems, as dancers undertake consecutive performances with short recovery periods. Ballet and contemporary have been described as mixed aerobic and anaerobic. Tap dance has been described as being of a high enough intensity and long enough duration to stimulate improvements in aerobic capacity. We're now going to watch the two performances by our lovely volunteers, Wei Chen and Aijia, in November and in the dance studio. The video will show you the dance side by side with the live data being collected. The equipment used is called the portable metallizer, and you can find more information about it in the Lab Skills course on Learn. The metallizer analyzes each breath for a number of variables, for example, heart rate, breathing rate and ventilation that we have spoken about. I will play each video for you and then discuss the graphs at the end of each. First up we have Aijia, who performed a Chinese folk dance called Dai, or Day. I can't remember how it was pronounced, my apologies. While you are watching, keep an eye on the data and think about what you are seeing in relation to the systems we have discussed. The highlighted boxes are the ones for you to look at for now. Some others I will discuss at the end. So look at the pattern of the heart rate, ventilation, so air moving in and out of the lungs from the external environment, and the rate of oxygen uptake and carbon dioxide production. There is a minute of rest at the start of each dance, so we could set resting level readings. So any data past the first line, so all of this data here and here and here is all the resting data. That's the minute that they were just stood still, and then the data after that is their dance. So in this first box you've got your ventilation, you're looking at the darker line at the bottom, your heart rate, you're looking at the top line in the second box, and then in the third box along is your oxygen uptake is the blue line, and your carbon dioxide production is the red line. Okay, so we can see that the heart rate, I get my pointer, apologies. See that the heart rate here is around 120 beats per minute at resting, which is quite high for a trained person, and is likely due to IJA warming up beforehand. If you were doing any testing, you would usually seat a participant for around 10 minutes to get an accurate resting measurement. At 1 minute, you can see here where she starts dancing, you can see an instant increase in heart rate as the muscles require a higher volume of blood to be transported to the muscles as they start working. As the heart rate reaches a maximum, at around 180 BPM, you can see it starts to plateau. This 180 BPM would be an age-estimated maximum. It would be around 180 for anybody in their 20s. Okay, ventilation. You can see a steady increase in ventilation here, and a proportional increase between oxygen uptake and carbon dioxide uptake. Carbon dioxide production, sorry, which would suggest that IJA is breathing efficiently and doesn't have an imbalance in too much carbon dioxide produced and not enough oxygen intake. This is what you would expect to see at lower intensities. The style IJA danced was of a lower intensity and for around 1.5 minutes, suggesting she was producing energy aerobically. This is confirmed in a way by the RER measurement. RER stands for the respiratory exchange ratio, and you can see that here and the graph of it over time here, but it's good to average out across the dance period. You get more of an idea of if it's a steady state dance, which we saw that it was quite steady state. There wasn't too many like peaks and troughs in intensity. You would see you'd be able to average out the RER there, because it would usually be indicative of the fuel or substrate use, and at a steady state that would usually be a mixture of fat and carbohydrates. Values closer to 0.7 are indicative of mixed fat use, and those closer to 1 indicate exclusive carbohydrate use. Bear in mind that fats can only be used as an energy source aerobically. Carbohydrates can be used both aerobically and anaerobically. IJA's RER averages at 0.86 when you average out the graph of her dance, indicating a mixture of fat and carbohydrate use. An indicator that IJA is performing a relatively steady state exercise is the ventilation VO2 and ventilation VCO2 graph, which is the third one that I meant, this one. You can see that both measures remain fairly constant and proportional to one another. This indicates an absence of an anaerobic threshold, which is the point at which your body needs to shift from aerobic to anaerobic metabolism. This is commonly found in incremental work as exercise intensity increases. The body needs to switch to anaerobic metabolism as the aerobic metabolism is no longer possible at high intensities. So once you've been working and it's getting higher in a higher intensity, say you start jogging and then you reach a sprint, for example, your body needs to switch from that using oxygen to using anaerobic metabolism, because we've switched to a higher intensity. We no longer have the time to break down oxygen for energy. The point at which this anaerobic threshold occurs would be visible on this graph by a systematic increase in oxygen without a concomitant increase in the VCO2, which is the red. But as you can see, they both follow a similar pattern. We watch Wei Chen's jazz routine that she performed for us. She actually did it twice. The first time she danced it, the equipment sort of came apart. The bit that measures your breathing came out of the mask. So she had to do it again. So just be aware of that when we look at the data. Okay, here we go. So we've got the data here. Get my pointer, sorry. So we can see that heart rate follows a similar pattern to IJA, starting at around 120, 130 beats per minute. Again, she had just done the routine, Wei Chen, so it could be higher because she didn't have a full recovery period from the last dance. But it still increases very steadily, and then you can see it plateauing at about 180 again. Again, there was a similar steady increase in ventilation and a proportional increase in oxygen uptake and carbon dioxide production, which would suggest that Wei Chen is also breathing efficiently, but towards the end of the routine you can see a slight jump in oxygen uptake than carbon dioxide production, which may indicate that Wei Chen's jazz routine is of a slightly higher intensity than IJA's Dai dance. But there are better ways to measure intensity. I'll discuss this in a second. So Wei Chen's RER average was slightly higher here. This could be because of a higher carbon dioxide production because she didn't get full time to recover. It could be for a variety of reasons, but it drops quite significantly. So we've averaged out that her RER was 1.02, which would indicate a greater reliance on carbohydrate use. But this could be both aerobic and anaerobic, as the performance is over a minute long and of a relatively low intensity. It looked like slightly higher intensity than IJA's, so you might assume that Wei Chen was working in both aerobic and anaerobic energy systems, using her glycogen stores and blood glucose. Again, you can see that the performance was fairly steady state, as the VE VO2 and VE CO2 are proportional to one another. There's a slight crossover here, but it's not the big increase in oxygen uptake in ventilation with not the same in carbon dioxide, so we would say that this is fairly a steady state and proportional to one another here. Another measurement that is produced from the data is oxygen uptake relative to body weight. This measure is used when testing maximal oxygen uptake, but this requires an incremental exercise test to total exhaustion. It usually involves running or cycling, but I think a rowing protocol has also been made quite recently. There is no such test that's specific to dancers. There's not really any dance that we've found that researchers have found to take you to exhaustion really within a short amount of time. But hopefully one will be in the works sometime soon, so that we're not trying to make dancers run for 15 minutes anymore. But anyway, the data for VO2 per kilogram which you can see here, of each performance would be useful to compare to the results of a maximal test to find out the actual intensity of the performance for that person, and it could be used for training methods, improving training methods. For example, if a performance was 40% of your maximal intensity, you can make sure that your training program meets or exceeds that performance demand, so that you are totally prepared to perform safely and efficiently. Looking at this graph, however, we can't work out the intensity of the pieces, but we can see that Wei Chen's piece was of a slightly higher intensity towards the end than Aija's, as the oxygen uptake is higher. Okay, well, I hope this has been of some interest to you all and given you an idea of what physiology encompasses and some idea of the types of research that you can do. If you do have any questions, let me know. I'll leave my email at the end if you want to email me. I've highlighted some of the references in bold as they are the texts that I found particularly helpful over my studies of physiology theory. So that's these four here. This McLaren and Morton, that was more specifically biochemistry, so that will cover your energy systems in quite a bigger depth. But for easier to sort of grasp or follow, Kenny is a good book to get stuck into, and McArdle as well if you're more interested in the deeper exercise physiology. I think that's it from me, so thank you for your time. Hopefully I'll actually meet some of you this year, and if you guys need any advice for your dissertations or anything or ideas, yeah, get in touch. Thank you for listening. There's my email there, so thank you.